Hello. In the previous videos, I demonstrated normal SISEN operation, packet capture, controlled attacks, attack category examples, Wireshark investigation, and wireless infrastructure activity. In this video, we focus on reporting and analysis. The objective is to convert technical observation into structured security-informed safety argument. So we're going to download the worksheet. We're going to use the worksheet for this. You can download it from the SISEN website or from the SISEN repository by going to the teaching materials, resources, and you will find it next to all the documentation that you can use to complete your lab activities. The other analysis sheet document. I've already opened it here. And this worksheet is not really intended to produce a generic statement. For example, a cyber attack could cause harm. Instead, it requires the user to trace a defensible chain. It's a storyline from when the incident happened all the way to the evidence you collected, so that you are able to demonstrate that you understand what happened, what evidence supports that conclusion, which security property was weakened, how the system responded, which unsafe state could result, what consequence could follow, which control could reduce the risk, what residual risk remains. This is a full security-informed safety argument that you can build for any activity that happened during that attack. So this worksheet provided, of course, as a Word document so that you can enter responses, insert screenshots, and reference packet captures or terminal output directly. So you can see here that every time you open it, you can choose which scenario, your student name and group, date, which system or subsystem you're observing. For example, are you observing a particular system in the scenario or the whole scenario? System effect, mode used, for example, the namespace, the hardware access point instructions, the number of nodes, and so on, and normal behavior before the event. You just describe briefly the baseline dashboard state, telemetry, traffic, logs, anything that you've seen. These sections are ordered deliberately in this way so that you can move from observation to interpretation. And you should not begin with a hazard statement and then search for evidence to support it. You should follow that logical order. The analysis should begin with the observed system and the evidence collected during the activity. And then we move to the evidence record. Now, in the evidence record, we have this section specifically records the evidence used to support the analysis. And the evidence should be identifiable and reproducible. So, for example, you can enter entries such as recaptured or logged references for safety gas leak hidden, or for specific attack timestamps that you've seen. And these evidence can be summarized by before the event where the gas state topic and the dashboard showed normal condition and unupdated with the normal publication pattern, and then after the event during the bounded attack, for example, you can see that the same topic carried safe looking gas state while the attacker helped report that gas leak telemetry was being hidden. And the dashboard, of course, will reflect the injected state. The idea is that this capture should include enough detail to find the evidence again. That's the reproducible statement here. You're including file names, timestamp, packet captures, packet numbers, interfaces, the different MQTT topics that were affected, which commands were used, and screenshots. For example, you can say Wireshark showed the attack is not really specific enough. Instead, you show all of those details. And I would suggest in here, you can place screenshots and packets or terminal screenshot into the worksheet placeholder to show exactly what was happening in a particular packet during that attack. Now, in the security event characterization, this is where you need to demonstrate, this is where you need to classify the security event. So, for example, the activity injected. So the security event observed, the classification must be supported by the evidence. For example, the activity injected telemetry that represents the gas condition or normal, causing the dashboard to display a safe-looking state. And you can show, for example, the event type, maybe data manipulation or suppression. You can specify which helper types, helper commands or scenarios were used. You can specify which assets were affected. For example, select smart building, gas sensor topic, MQTT broker, dashboard interpretation. Whichever asset was affected, you should record it. Security property weakened. For example, which property was weakened? Was it integrity? Was it authentication? Was it confidentiality? Was it availability? Evidence support this classification. Explain why the dashboard, packet capture, MQTT output, terminal log, or anything else supports your classification. For example, you can say something like, the injected MQTT message used the expected topic structure, were accepted by the broker and the dashboard, and the payload control contradicted the safety relevant condition represented by the activity. So you can see the differences between what was reported in the dashboard and what the payload you are sending was. So you can show the differences in terms of the integrity of the message or the authenticity of the message since you're sending both messages. And the selected property should not be limited to those supported by observed events. For example, integrity is weakened because the content is incorrect. Authenticity may also be weakened because the dashboard accepts the message without distinguishing injected source from legitimate source. And then we move to security system effect. Now, when we're talking about the system effect describes what the system did, not what the attacker intended. So, for example, the observed system change, you can give an example in terms of the gas state attack. The dashboard, for example, the dashboard gas state field changed to a safe-looking condition during the bounded attack. You know what the attacker was sending at that point. The system response accepted data event, misinterpreted data event, duration, how you can recover it, was it temporary, was it repeated, was it recoverable? How do you know that the system returned to normal operation? Did you have to stop the system and clean it up, or was it automatically done after the attack stopped? Affected parties or functions, building operator, occupants, or any monitoring or alarm function relying on the gas state telemetry. And what the system appeared to believe. The monitoring system appeared to believe, for example, that the selected zone did not contain a gas hazard. The distinction is important because the security event is the manipulation or the suppression of the telemetry. However, the system effect is what we are looking at, which is whether the dashboard accepted and displayed the incorrect state. The worksheet, you should record on that worksheet the observable system behavior rather than assumption about internal interpretation. You should record what you've seen in the system. And then we move to the safety hazard analysis. This is where we convert the observed system effect into a safety relevant hazard analysis. And the worksheet provides the following structure. You can see the unsafe state, where a zone, for example, containing gas hazard may remain represented as safe. The decision, action, or automation impact. The operator, maybe they did not initiate ventilation or isolation or investigation or evacuation simply because the dashboard was reporting safe state. Possible safety consequences: occupants or responder may be exposed to hazardous gas, or ignition or escalation may occur where the gas is flammable simply because the dashboard is reporting safe state. And linked to observed cyber events, you link it directly to the cyber events. So, for example, direct and indirect. For example, you can say real gas leak exists during the telemetry manipulation. The dashboard is used to support operational decision. There is no independent local detector or second verification that overrides that false reading, and you are receiving spoofed data. The assumption field prevents, if you look at the assumption field, the assumption field prevents the analysis from overstating what the laboratory activity proves. You're making assumptions. What were the assumptions for the safety analysis? And the lab demonstrates that telemetry path can display an incorrect state. It doesn't prove that a real gas leak occurred. The safety consequences therefore depend on additional assumption, which should be stated explicitly. A real gas did exist during the telemetry manipulation or not? The dashboard is simply used to support the operational decision. There's no independent local detector. You cannot really verify whether there were a real gas leak or not. And the other statement is, because the gas leak telemetry is manipulated or suppressed, the smart building monitoring system may represent a hazardous zone as safe, leading to delayed protective action and possible occupant exposure to those hazardous gas. And finally, mitigation, assurance, and residual risk. This section separates controls that reduce the cybersecurity event from controls that reduce the safety impact, because there are two different there are two different types of controls. This separation is important because preventing the attack and limiting the consequences of an attack are not the same. For example, to reduce the cybersecurity event, you can have mutual authentication between publisher and broker, or per topic authorization, or message integrity protection. However, to put controls to reduce the safety impact, maybe you might need an independent local gas alarm, fail-safe response when telemetry is inconsistent, or secondary sensor verification. And the idea is, what would reveal the event during the operation? For example, evidence for detection or monitoring, alert or unexpected publishers, detect conflicting values. These are detection or monitoring that are happening in real time. That says, not that the states are changing, but there's an attack happening. Something is abnormal happening and requires a verification or requires a second validation. Evidence that mitigation are working. For example, what do you propose to do? You try to conduct another attack and it's rejected or quarantined. The dashboard shows untrusted or unknown state rather than the injected safe state. That's quite important, because that means that at least the dashboard is telling you that the values we're receiving are not the normal state or untrusted state. So we're not really showing them as trusted values. And then finally, residual risk. Legitimate publisher, for example, or credential may still be compromised. The idea of this section is that the assurance evidence field should describe how the mitigation will be tested, and it's not enough to state that authentication or anomaly detection should be added. You should identify what observer result would demonstrate that the control worked. And finally, the final security safety argument is that you should summarize the complete argument. And you should remain concise, but you must preserve the full causal chain. For example, the final argument should be traceable and from all the earlier worksheets. You should not introduce a new hazard, new mitigation, or assumptions that you didn't previously discuss. For example, the Gadley hidden activity manipulated safety relevant smart building telemetry on the MQTT dashboard trust pass. The broker and dashboard accepted the injected safe looking values, weakening telemetry integrity and authenticity. This caused the monitoring interface to represent the selected zone or safe as safe during the bounded attack. So we're looking at all the different chain of events. If a real gas leak existed and the dashboard were relied upon for operational decision, protective action could be delayed. That's the consequences, creating a risk of occupant exposure or ignition. Publisher authentication, topic authorization, message integrity checks would have helped protect or mitigate or reduce the risk. Residual risk remain if authorized publisher, credential, or independent detection mechanism are compromised or unavailable. This is a summary of all the different sections. This is the final argument that connects the security risk with the safety implication, with the security control and the safety control and the residual risk. Strong evidence is specific and is linked to the claim it supports. A useful discipline is always to support these kind of statement and observation is directly supported by. So in this video, we demonstrated how to complete the SISEN hazard analysis and evidence sheet, and we identified the whole chain of events, the security events, the affected components, the weakened security property, the observed system effect, unsafe state, possible consequence, mitigation, assurance evidence, and residual risk. The key principle when you're doing those activities is that a security-informed safety argument must preserve the full chain from evidence to consequence. And this is what SISEN tool is intended to. It's intended to support repeatable, controlled learning activities in which cybersecurity behavior is examined, not only technical event, but also possible contributor to unsafe system behavior. Thank you.